welcome back to my videos. As you can see, I don't have the normal setup where I'm traveling somewhere else, definitely not in front of a green screen. I instead decided to do it right here in my classroom today because it's just going to be a quick video, so I figured why not have a nice change of pace. So in the PowerPoint from yesterday, you talked a little bit about electromagnetism and what it is. So remember that electromagnetism is magnetism produced by an electric current. Specifically, an electric current flowing through a wire creates a magnetic field that surrounds the wire in circles. Now, if you remember seeing on the PowerPoint, you can make your own magnet by taking a battery and then wrapping wire around a nail, connecting the positive and negative ends of the battery to the wire wrapped around the nail, and then you can pick up certain magnetic metals, like paper clips. What you do when you wrap the coil around the nail is you're making what's called a solenoid. And a solenoid is a coil of wire with electric currents flowing through it. So in the example I just gave, the battery, when the wire connects the negative end to the positive end, creates a current through that wire. And then when it's the wrapping motion around the metal nail is actually what's creating the solenoid. So when you have the solenoid, the electric current that's flowing through it produces a magnetic field with north and south poles because of the shape of it. The magnetic field created by the coiled wire is stronger than a straight wire, and the reason being is because every coil gives off its own magnetic field. So when you have a bunch of different coils pieced together, all their magnetic fields will combine and become one big one. The more coils there are, the stronger the magnetic field. Another way that you could increase the strength of the magnetic field is to also increase the amount of current passing through the solenoid. Solenoids are typically used to convert electromagnetic energy into motion. These are often used in devices that need a sudden burst of power to move a specific part. And a good example is going to be posted right here. If you're not familiar with what this is a pinball machine. And the solenoids are used in the bumpers and the switches and the different moving parts, which helps the ball move around and bounce around. So we talked about electromagnetism and we talked about solenoids. So if we combine those two together, we get an electromagnet. What's an electromagnet? It's a solenoid wrapped around a bar of iron or other ferromagnetic material. So ferromagnetic material is iron, cobalt, nickel, any material that can be magnetized. Now, electromagnets are very strong. In fact, they're the strongest magnets that you can make. And they're very strong because the magnetized wire coil and the ferromagnetic bar work together. So remember, with the solenoid, the coil wire, the more coils you have, the stronger the magnetic force. When you add the current flowing through it, the more current you have, the stronger the force. And then the bigger the bar, or the easier it is to magnetize because different types of material are easier to magnetize than others, then the stronger the electromagnet is. Now remember, to be able to be magnetized, it's considered ferromagnetic material. What's the benefit of an electromagnet? So one benefit is easy on and off. When you have the electricity turned on, the electromagnet is on. When you turn the electricity off, the electromagnet turns off. What's another benefit? You can change the level of current to change the strength of the magnet. Say you needed a pretty strong magnet, but not too terribly strong, you can adjust the current, which will then adjust the strength. Or if you are, say, picking up a car with a magnetic crane, you want to have it pretty strong. I mean, cars are pretty heavy. So depending on the different car or style of vehicle, the weight's going to differ. And because of that, you're going to need different strengths to pick the vehicle up. So if you have a little tiny smart car, you can adjust the current so it's not as much. Or if you have a big truck, then you would increase the current to increase the strength and make it strong enough to pick up the truck. How else are electromagnets used? Common devices are doorbells and electric motors. Doorbells are set up similar to the old school bells like this one. Which we don't have anymore. Our bell system's totally different. But back in the day, you had these bell systems that would tell you when to move classes, and the bells worked by use of an electromagnet. There's a full circuit, but it's not fully on because of the button. So when you push the button, it causes the two electric contacts to come together and completes an electric circuit, which we'll talk about in a little bit. And by a little bit, I mean a few days. So the button is essentially a switch, like a light switch. You push the button, the electric current is completed in the circuit, and so the current flows through. When the current flows through, it goes around the wrapped coil. What? Yes, a solenoid that's wrapped around a magnet. So when that happens, the electromagnet becomes magnetic and draws a clapper closer until it hits a bell. Then when you let go of the button, the electric current stops, the electromagnet is no longer magnetic, and the clapper moves back to its original position. So if you sat there rapidly pushing the button, then the clapper would just go on and off, hitting the bell. Or if you hold it and keep the circuit going, then it'll just keep ringing and ringing and ringing. Another real-life use is the electric motor. So an electric motor is a device that uses electromagnets to change electrical energy into kinetic energy. Now, I feel like we've talked about kinetic energy before. Does anyone remember what it is? No? What? Yes, kinetic energy is the energy of movement. So it means it's taking electrical energy and making something move with it. So electric motors contain an electromagnet inside of it, and it's connected to a shaft. So when the current flows through the motor, the electromagnet rotates, which causes the shaft to rotate as well. And then the rotating shaft moves other parts of the device. So if you had the electromagnet and then the shaft that are connected, and on either side of the shaft you had wheels, then when the electromagnet is on, the shaft rotates, which in turn causes the wheels to rotate, and then it causes it to move in one direction or the other, depending on which way the rotation is occurring. Now, why does the electromagnet rotate? It rotates because it's located between the north and south poles of two permanent magnets. When current flows through the electromagnet, it becomes magnetized, and its poles are repelled by the poles of the permanent magnets. So if you've ever held magnets together, the north side and the south side can touch. But if you try putting the north side and the north side together, it doesn't touch. Or south side, they can't touch unless you really force them to. But if you have a strong enough magnet, they won't touch. So since they're like poles of the permanent magnets versus the electromagnet, they won't touch. This causes the electromagnet to rotate toward the opposite or the unlike poles of the permanent magnets. So instead of being north-north, the electromagnet moves from north to south, and then it repeats. So it just creates a rotation. I know this was a quick video. We're gonna increase our length of the videos as this new marking period goes on. But remember, this is a new marking period, so make sure you guys are turning in your assignments. And as always, if you have any questions, please reach out to your teacher, whether that's Miss Cameron or myself. Bye.